Hello everyone. In this lecture, I will discuss about the how to solve the linear programming problem by simplex method. I will discuss with one example problem. The problem is use the simplex method to solve the following linear programming problem. Minimize z equal to x1 minus 3x2 plus 2x3 subject to constraints 3x1 minus x2 plus 2x3 less than or equal to 7 minus 2x1 plus 4x2 less than or equal to 12 minus 4x1 plus 3x2 plus 8x3 less than or equal to 10 x1 x2 x3 greater than or equal to the 0. Let's see the solution. Here observe that one given problem is minimize the objective function. When the objective function is minimized, then first we have to convert to maximization problem by multiplying with the minus 1. So objective function is maximize z equal to minus 1 into minimize z. So that is equal to the minus x1 plus 3x2 minus 2x3. Then first step is convert the inequality of the constraints into equation by introducing slack variables. So here one more thing we have to observe that one we have to add the slack variables because here given inequality symbols in the constraints are less than or equal to. So we have to add the slack variables. Here three constraints are given. So we have to introduce the three slack variables, that is S1, S2, S3 in the constraints 1, 2, 3. So now the constraints are 3x1 minus x2 plus 2x3 plus S1 equal to 7 minus 2x1 plus 4x2 plus S2 equal to 12 minus 4x1 plus 3x2 plus 8x3 plus S3 equal to 10 and x1, x2, x3, S1, S2, S3 all are greater than or equal to the 0. And objective function is maximize z equal to minus x1 plus 3x2 minus 2x3 plus 0s1 plus 0s2 plus 0s3. Next step is find the initial basic feasible solution. For this, assume that decision variables x1, x2, x3 are the 0 and we have to substitute in the constraint equations. Then S1 will become the 7, S2 will be 12, S3 equal to 10. Next step is write the standard form of LPP into matrix form, that is A is equal to B form. Here A is the m by n matrix of quotients of the variables for the constraints equation and X is the columnar matrix of the basic variables, that is x1, x2, x3, s1, s2, s3. Similarly B is the columnar matrix of the right hand side values in the constraint equation, that is 7, 12 and 10. So then write the matrix form. First we have to write the all the basic variables, that is x1, x2, x3 and s1, s2, s3. Then write the constraints coefficients of these variables for the constraint coefficient, that is so 3, minus 1, 2, 1, 0, 0. Why it is 0, 0 mean in the first constraint there is the no S1 and S2. Similarly, based on the second constraint, here I have to write down all the coefficients for the basic variables. So minus 2, 4, there is a no x3, so that's why it's a 0. So no S1, so 0. So S2 coefficient is the 1, there is a no S3, so it is the 0. So next we have to go for the third constraint. Here I have to observe that one coefficients for the basic variables are, first one is the minus 4 for the basic variable x1, minus 4, next 3 and 8. So here there is a no S1 and S2, so it is the 0, 0 and the S3 coefficient is the 1. So next we have to write down the columnar matrix of the all the basic variables, that is x1, x2, x3, s1, s2, s3. After that one we have to write the columnar matrix of the right hand side values of the constraint equation. So that is B equal to columnar matrix of 7, 12 and 10. And next step is construct the initial simplex table. So this is the initial simplex table. Here Cj is the cost coefficient for the decision variables and slack variables, that is -1, 3, -2, 0, 0, 0. And Cb is the initial coefficient for the slack variables. We know that one, the initial coefficient for the slack variables are the 0, 0, 0. So here I have to write down the 0, 0, 0. And B is the basic slack variables. We know that one, the basic slack variables are the S1, S2 and S3. Here I have to write down S1, S2, S3. Next, XB is the initial basic feasible solution for the slack variables. Here already we determined the initial basic feasible solution and we are obtained the S1, S2, S3 values are the 7, 12 and 10. So here I have to write down the 7, 12 and 10 values. And here we have to write down the coefficients for the variables which is observed from the constraint equations. So here I have to fill the all the coefficients for the these basic variables. So that is 3, -1, 2, 1, 0, 0 from the first constraint equation and -2, 4, 0, 0, 1, 0 from the second constraint equation, -4, 3, 8, 0, 0, 1 from the third constraint equation. Next step is calculate the values of Zj minus Cj and check the basic feasible solution for optimality. We know that one, Zj minus Cj equal to Cb into Xj minus Cj. So first we have to calculate the Z1 minus C1, which is equal to the Cb into X1 minus of C1, which is equal to the Cb into X1 means 0 into 3 plus 0 into -2 plus 0 into -4 and C1 value is the -1. So it will be minus of -1. So total this value will become the minus into -1 which in the 1. So you have to enter the 1 value here. Similarly, you have to calculate the Z2 minus C2, which is equal to CbX2 minus C2. CbX2 means 0 into -1 plus 0 into 4 plus 0 into 3 minus C2. C2 value is the 3. So the value will become -3. So enter the -3 value here. So next we have to determine the Z3 minus C3, which is equal to CbX3 minus C3. CbX3 will become the 0 into 2 plus 0 into 0 plus 0 into 8 minus of C3. C3 value is the -2. So total value will become the 2. So have to enter the 2 value here. So next we have to determine the Z4 minus C4, which is equal to the 0 into 1 plus 0 into 0 plus 0 into 0 minus of C4 value, that is the 0. So total value is the 0. So enter the 0 value here. So next we have to determine the Z5 minus C5, which is equal to CbX5 minus C5. CbX5 is the 0 into 0 plus 0 into 1 plus 0 into 0 minus of C5 value, which is the 0. So the value will become the 0. So enter the 0 value here. Finally, we have to determine the Z6 minus C6, which is equal to CbX6 minus C6. Then CbX6 equal to the 0 into 0 plus 0 into 0 plus 0 into 1 minus of C6 value is the 0. So total value is the 0 and then have to enter the 0 value here. After find out the Zj minus Cj, just we have to check the 3 conditions. First condition is if all the Zj minus Cj is greater than or equal to 0, then the optimal solution is obtained. Second condition, we have to check at least one Zj minus Cj is negative, then indicated by arrow, and this column we are calling as the key column. Third condition is if more than one Zj minus Cj is the negative, then we have to choose the most negative value and respected column we are calling as the key column. Here I have to observe that one Zj minus Cj values. Here we are getting the only one negative value of the Zj minus Cj, and this respected column we are calling as the key column. So here x2 column we are getting the Zj minus Cj value is the negative, and so x2 column we are calling as a incoming vector. So this is the incoming vector. Next step is we have to calculate the minimum ratio of xp by ck. Here ck is the key column, that is x2, and one more thing we have to remember, we should have to calculate the xp by ck if the value of the ck element is positive only. If the ck element is the negative, then we have no need to calculate the xp by ck ratio. So first we have to calculate the xp by ck ratio for the 7 value, and we have to observe that one respected ck value is the -1. If the ck value is the negative mean, we don't need no need to calculate the xp by ck. So next we have to calculate the xp value is the 12. For the respected ck value is the 4, and the xp by ck equal to the 12 by 4, that is 3. So next xp value is the 10, and respected ck value is the 3, and xp by ck will become the 10 by 3, that is the 3.333. So among these two values we have to identify the minimum value, that is the 3, and respected row variable we are calling as the outgoing vector, that is the s2. After that one we have to identify the common element in the key row and the key column. So this is the key row and this is the key column and this is the key row, and here we have to observe that one common element in the key row and key column, that is the 4. So that element we are calling as the common element. So here 4 is the common element. So next we have to construct the new construct table by entering the incoming vector, that is the here x2 is the incoming vector and s2 is the outgoing vector. So once again we have to construct the new simplex table, and this is the new simplex table. Here we have to observe that one x2 as the incoming variable and s2 is the outgoing variable. So we have to replace the x2 in the place of the s2, and also have to modify the cv values as the 3 because x2 cost coefficient is the 3. In addition, we have to modify the all the row 2 values, like so row 2 divided by key element. Here key element is the 4. So row 2 elements are 12 divided by 4, -2 divided by 4, 4 by 4, 0 by 4, 0 by 4, 1 by 4 and 0 by 4. So the values will become 12 by 4, that is a 3, -2 divided by 4, -1 by 2, 4 by 4, 1, 0 by 4, 0, 0 by 4, 0, 1 by 4 and the 0 by 4, that is the 0. After that one, so you have to observe that one previously S1, S2 and S3 are the identical matrix, and also their values are 1 0 0, 0 1 0, 0 0 1. Now S1, X2 and S3 are forming identical matrix, and their values also should be the 1 0 0 0 1 0 0 0 1. So first we have to fill these values in the new table, that is S1 versus S1, it should be 1, remaining S1 X2 0 and S1 S3 0. Similarly, X2 and X2 already we got it 1, remaining X2 and S1 0, X2 and S3 also 0. Similarly, S3 S3 1, remaining S3 and S1 0, S3 X2 is the 0. So next we have to modify the remaining values. So how we are modifying the remaining values? It should be like old element into key element minus of multiplication of opposite diagonal elements divided by the key element. So first we have to take the element is the 7. So old element is the 7. After that we have to identify the key element. So 7 and the 4 key element. Then we have to identify the opposite diagonal elements, that is the minus 1 and 12. So enter the minus 1 and 12. Then we have to do this calculation, that is old element into key element minus of multiplication of opposite diagonal elements divided by the key element. So here 7 into 4 minus of minus 1 into the 12, so divided by the key element, that is the 4. So value 28 and minus of minus, it will become the plus. So 28 plus 12, so total 40, 40 divided by 4, it will become the 10. So enter the 10 here. Similarly, next old element is the 3 and we have to identify the key element is the here. Next we have to identify the opposite diagonal elements, that is the, so 3 and 4. Here opposite diagonal elements for the 3 and 4 is the minus 1 and the minus 2. So same calculation I have to do here. Old element, that is the 3 into key element, that is the 4, 3 into 4 minus of minus 1 into minus 2 divided by the key element. So 3 into 4 minus of minus 1 into minus 2, it will become the 2 plus 2, and 12 minus 2 is a 10, 10 divided by 4, it is a 2.5. So enter the 2.5 value here. So next element is the here x3 here, so for the 2. So old element is the 2 and we have to identify the key element is the here. For the opposite diagonal elements for the 2 and 4 is the minus 1 and 0, and do the calculation old element into key element minus of multiplication of the opposite diagonal elements divided by the key element, that is 2 into 4 minus of minus 1 into 0, it's a 0, it should be the value is the 2. So enter the 2 value is here. So next one is the, so here, so S2 value here, so old element is the 0 and we have to identify the key element is here. For these two opposite diagonal elements are the minus 1 and the 1. So do the calculation old element into key element, so minus of multiplication of the opposite diagonal element divided by the key element. So old element is the 0, key element is the 4. So 0 into 4, this is the 0, and minus of minus 1 into 1, that is the plus 1 divided by the key element is the 4. So value is the 1 by 4, just have to enter the 1 by 4 here. Similarly, you have to do the, so next elements here, this old element is the 10 and you have to identify the key element is the here, and you have to identify the opposite diagonal element, that is the 12 comma 3, and do the, so calculation like old element into key element minus of multiplication of the opposite diagonal elements. So here old element is the 10 and the key element is the 4. So multiplication of the old element and the key element and opposite diagonal elements is the 12 and 3. So 10 into 4 minus of 12 into 3. So 40 minus 36, that is the 4. 4 divided by 4, it is the 1. So enter the 1 here. So next one is the, So here, so for this one x1, this is the -4. So -4 is the old element, and diagonal and the key element is the here, and opposite diagonal elements are the -2 and 3, and have to do the calculation old element into the key element, that is the 4 into -4, that is the -16, and minus of multiplication of opposite diagonal elements, that is the -2 into 3, that is the 6. So -6, so minus of -6, it will become the 6, and this is the -16. So -16 plus 6, it will be 10. 10 divided by 4, it will become the 2.5. So enter the 2.5 value here, and next element is the, so next element is here 8, and we have to identify the key element is the here. For these two opposite diagonal elements are the 0, 3. Enter the 0, 3 here, and have to do the calculation old element into the key element minus of multiplication of the opposite diagonal elements divided by key element, that is 8 into 4, 32, minus of 0, 32 divided by 4, that is the 8. Enter the 8 here. So next element is the here, so this value is the 0, and we have to identify the key element is the here, and opposite diagonal elements are the, for these two is 1, 3. So 1, 3 had enter here and do the calculation. So we will get the 3 by 4. So enter the, sorry, we will get the -3 by 4. So we have to enter the -3 by 4 value here. So this is the new simplex table. Here once again we have to determine the Zj minus Cj values. So Z1 minus C1 will become the CBx1 minus C1. So CBx1 will become the 0 into 2.5 plus 3 into -1 by 2, 0 into 2.5 minus C1. Here C1 value is the -1. So minus of -1. So this value we will get the minus 0.5. So enter the Zj minus Cj. So Z1 minus C1 value here, that is the minus 0.5. So similarly next we have to calculate the Z2 minus C2. So that is the, so 0 into 0 plus 3 into 1 plus 0 into 0 minus of C2, that is the -3. So value we will get the 0. So enter the 0 value here. So next Z3 minus C3, that is 0 into 2 plus 3 into 0 plus 0 into 8 minus of C3, that is the -2. So minus of -2. So this is the 0, and minus of -2 we will get the 2. So enter the 2 value here. So next we have to find out the Z4 minus C4. So which is equal to the 0 into 1 plus 3 into 0 plus 0 into 0 minus of C4, that is the value is the 0. So here total we will get the 0. Enter the 0 value here. So next we have to find out the Z5 minus C5, which is equal to the 0 into 1 by 4 plus 3 into 1 by 4 plus 0 into minus of 3 by 4 minus of 0. So C5 value is the 0. So that's why minus of 0. So total this is will get the 0 and 0 minus 0. Sorry. Here, so 3 by 4 we will get 3 by 4 minus 0. So we will get the 3 by 4. So enter the 3 by 4 here. So next finally we have to determine the Z6 minus C6. So which is equal to the 0 into 0 plus 3 into 0 plus 0 into 1 minus of 0. So here total value we will get the 0. So enter the 0 value here. And next we have to observe the 3 condition, whether all Zj minus Cj values are greater than or equal to 0. If all Zj minus Cj is greater than or equal to 0, we get the optimal solution. Second condition is, if at least one Zj minus Cj is the negative, then we have to indicate it by arrow. This column we are calling as the key column. And if the more than one Zj minus Cj is the negative, then choose the most negative value, and respected column we are calling as the key column. Here second condition is satisfying. Here we are getting the only one negative value for the Zj minus Cj, that is the minus 0.5. for the respected variable is the x1 variable. So x1 variable we are calling as the incoming variable. And next we have to calculate the xb by ck values. And first we have to calculate the xb values. So that is the 10 and ck is the key. So here x1 is the key column, respected values have to divide it by the respected element values. So here 10 divided by 2.5, that is the 4. So next xb value is the 3 and ck value is the minus 1.2. So for this one we are not calculating. Why mean? If we are calculating only for the positive values of the ck elements. Similarly, 1 divided by minus 0.25. So for this one also we are not calculating. Why mean? So ck element value is the negative. So among these values, only we are having the only one value. So minimum value is the 4 only. So for that one, so minimum value is the 4 and indicated by the arrow. And respected value is the S1. Sorry, here it is the S1. So S1 is the outgoing vector. So next, once again, we have to identify the common element in the key column and the key row. Here 2.5 is the common element. So after that one, once again we have to construct the new simplex table by entering the incoming vector. So this is the new simplex table. Here I have to observe that one x1 is the incoming variable and s1 is the outgoing variable. So I have to replace the x1 value in the place of the S1 and also have to modify the CB value as the minus 1. So why? Because so x1 coefficient is the minus 1. So in addition, we have to modify the row 1 as row 1 divided by the key element. Here key element is the 2.5. So row 1 elements are 10 divided by 2.5. Similarly, 2.5 divided by 2.5, 0 by 2.5, 2 divided by 2.5, 1 divided by 2.5, 1 by 4 divided by 2.5 and 0 divided by 2.5. So row 1 values will become 10 divided by 2.5 it is the 4, 2.5 divided by 2.5 1 and 0 by 2.5 it is the 0, 2 divided by 2.5 so nearly it will be 4 by 5. So next 1 divided by 2.5. So it will become the nearly 2 by 5 and next one is the 1 by 4 divided by 2.5. So it is the 1 by 10 and 0 by 2.5 it is the 0. So next we have to observe that one previously. So previously S1, X2 and S3 are the identical matrix. Now X1, X2 and S3, these three are the identical matrix. So previously S1, X2 and S3, these values are become 1 0 0 0 1 0 0 0 1. Now X1, X2 and S3 are the identical matrix and these values also should be 1 0 0 0 1 0 0 0 1. So now we have to fill these values in the new table. That is, let's see here. And x1 is the 1, already we got the 1. Now x1, x2 already we got the 0. Next x1 and s3 it is also 0. Similarly x2 it is the 1 and x2 and x1 it is the 0 and x2 and s3 this is the 0. Similarly s3 1 and s3 x2 is the 0. X3, S3 and X1 it is also 0. So next we have to modify the remaining values. It should be like old element into key element minus of multiplication of opposite diagonal elements divided by the key elements. So next we have to modify the remaining these values here. So xb value is the here xb and x2 this is the 3. So first we have to identify the Old element is the 3 and the key element is the 2.5 and opposite diagonal element are the 10 and minus 1 by 2. So old element it is the 3 into key element that is the 2.5, 3 into 2.5 minus of multiplication of opposite diagonal elements. For these two opposite diagonal elements are the 10 and minus 1 by 2. So 3 into 2.5 minus of 10 into minus of 1 by 2 divided by 2.5. So these values should be 10 point, so 7.5 plus 5 should be, so it will be nearly, so 5. So value we will get the 5, so enter the 5 value here. So next here we have to determine the, have to modify the here. So old element for this one is x2 and x3. So x2 and x3. So for this one we are identify the 0 and the key element is the 2.5. So for these two opposite diagonal elements is the 2 and minus 1 by 2. So here 0 into 2.5 minus of 2 into minus 1 by 2. So 2 into minus 1 by 2 divided by 2.5. Here we will get the value is 1 divided by 2.5. So enter 1 by 2.5 value here. And next element is the x2 and s1. So x2 and s1 value is the 0. So for the 0 have to identify the key element is the 2.5 and opposite diagonal elements are the, so it should be the 1 and minus 1 by 2. So here we have to enter these values 0 into 2.5 minus of 1 into minus 1 by 2. So divided by 2.5. So we will get the value is the 1 by 5. So enter the 1 by 5 here. 1 minute, we have to erase these values. Yeah. So next to similarly, and next to old element is the x2 and s2. So x2 and s2 value is the 1 by 4. So 1 by 4 here, and the key element is the 2.5 here, and opposite diagonal element is the 1 by 4 into minus 1 by 2. So here 1 by 4 into 2.5 multiplication. Similarly, multiplication of the opposite diagonal elements, that is the 1 by 4 into minus 1 by 2. So divided by key element, that is the 2.4. So value we will get the 3 by 10. So enter the 3 by 10. Similarly, you have to modify the remaining values for the third row. 1 minute, I will erase all the marking here. Yeah. So old element is for the S3 is here, that is the 1, and key element is 2.5. So 1 and 2.5, and the opposite diagonal elements are the, so minus 2.5 and the, so 10. So 1 into 2.5 minus of 10 into 2. So minus 2.5 divided by 2.5. So value we will get the, so 11. So enter the 11 here. So next element is the S3 and X3. So S3 and X3 here. So old element value is the 8 and the key element is the 2.5. So for this one, so diagonal elements are the 2 and so 2.5. So 2, 1, 2. So sorry, 1 minute. 2 into minus 2.5. So 8 into 2.5 minus of 2 into minus of 2.5. So divided by key element, that is the 2.5. So value we will get the 10. So enter the 10 value here. So next element is the S3 and S1. For the S3 and S1, the value is the 0. So key element is the 2.5 here. For this one, opposite diagonal element is the 1 and minus 2.5. So 0 into 2.5 and 1 into minus 2.5. 1 into minus 2.5 divided by key element value is the 2.5. So answer we will get the 1. So enter the 1 here. And the last, so last element value is S3 respected to the S2. S3 and S2 value is the minus 3.4. Yeah, so minus 3.4. So minus 3.4 is here, key element is the here. So multiplication of these two, minus 3.4 into 2.5, and opposite diagonal elements are the, so 1.4 and the minus 2.5. So this is the minus 3 by 4 into 2.5 minus of 1 by 4 into minus of 2.5 divided by key element value is the 2.5. So answer you will get the 1. So enter the 1. So sorry, here we will get the 1 by 10. Sorry, I did the mistake here. It will be 1 by 10. So enter the 1 by 10. So this is the new simplex table. Here once again I have to calculate the Zj minus Cj values and check the basic feasible solution for the optimality. So first we have to determine the Z1 minus C1, that is minus 1 into the 1 plus 3 into 0 plus 0 into 0 minus of minus 1. So the answer it will become, so 0. Similarly, so enter the 0 value here. Next one is the Z2 minus C2, so which is equal to the minus 1 into 0 plus 3 into 1 plus 0 into 0, so minus 3. So answer is the 3. So it will be the 0. So enter the 0 value here. So next one is the Z3 minus C3, which is equal to the, so minus 1 into 4 by 5 plus 3 into 1 by 2.5 plus 0 into 10 minus of minus 2. So answer will become 12 by 5. So enter the 12 by 5 here. So next we have to determine the Z4 minus C4. So which is equal to the minus 1 into the 2.5 plus 3 into 1 by 5 plus 0 into 1 minus of 0. So answer will get 1 by 5. So enter 1 by 5 here. And next one is the Z5 minus C5, which is equal to the, so minus 1 into 1 by 10, 3 into 3 by 10 plus 0 into 1 by 10 minus of 0. So this is the answer we will get 8 by 10. So enter the 8 by 10 here. And last one I have to determine the Z6 minus C6, which is will become equal to the, so minus 1 into 0 plus 3 into 0 plus 0 into 1 minus of 0. So we will get the 0, enter the 0 here. And observe the three condition. So first one is, if all the Zj minus Cj is greater than 0, we will get the optimal solution. And second condition is, if at least one Zj minus Cj is negative, then we have to indicate the arrow, and respected column we are calling as the key column. And next one is the, if the Zj minus Cj value having the more than one negative values, and choose the most negative, and respected column we are calling as the key column. Here we are getting the all Zj minus Cj values are the positive only. So all the first condition is all Zj minus Cj is greater than or equal to 0, then we are getting the optimal solution. So and the optimal solution here we are getting the x1 and x2 only. So here we are not getting the any x3 values, and respected values for the x1 and x2 are the 4, 5. So here all the Zj minus Cj is greater than or equal to 0, then we are obtaining the optimal feasible solution at x1 is the 4, x2 is the 5, and x3 equal to 0. Then I have to substitute in our objective function, that is the maximize z equal to, so minus x1 plus 3x2 minus 2x3. Here x1 value is the 4 and x2 value is the 5 and x3 value is 0. Substitute these three values in the objective function, we will get the answer is 11. So this is the maximize z. But given problem is minimize the z. So minimize the objective function. So once again we have to multiply with the minus 1 of the maximize. Sorry, here maximize. So maximize z, that is minus 1 into the 11. So answer is the minus 11. So this is the optimal solution, and the minimize z value is the minus 11. So thank you.